Namaskar everyone, Indian Master Ji welcomes you to this YouTube channel. In the last video, we saw the concept about continuous random variables, how it is represented, how it is illustrated, what is probability density function and properties of the same. If you haven't watched that particular video, I recommend please watch that particular video first and then see this video. I will put the description of that particular video in the description box and I will pin it in the I button also. Today we are going to take an example on the same concept. But before we start, a small request. After watching the video, if you find that the video was useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with today's question. This question is from May-June 2010, paper variant 71, question number 5. What is the question saying here? The random variable t denotes the time in seconds for which the firework burns before exploding, and the probability density function of t they have given by this particular equation. Okay, it is defined for this particular interval and for the rest of the part it is value is 0, and they are asking us certain things to find out. First thing what they have said, show that k is equal to 1 upon 5 times e minus 1. So how do we find out this k? What we know about probability density function? We know that the total area under the curve of the probability density function has to be equal to 1. Why? Because total probability is equal to 1. Correct? So we will use that particular concept. The total area under the curve of what? Curve of f of t. Here the probability density function, curve of f of t is equal to 1. Correct? So therefore can I say that because the total area under the curve is equal to 1, I can find out the area using the integration. So I'll integrate this particular area of f of t under the graph of f of t and I will equate it with equal to 1. So I'm integrating this f of t for all the real values of t. Correct? But in turn, we know that it is only defined for 0 to 5. It is having some sort of equation for 0 to 5 and for the rest of the values it is 0. Correct? So can I say from minus infinity to 0 f of t dt, I'll split this particular whole integration into 3 parts: 0 to t, 0 to 5 f of t dt plus 5 to infinity f of t dt. Okay, but for this particular value from minus infinity to infinity 0, for this particular interval f of t ka value is 0. So that means this integration will be 0. And for 0 to 5 interval, what is f of t? F of t is k times, it is k times e raised to 0.2 t. So this I will integrate with respect to t, plus from 5 to infinity interval, okay, f of t is again 0, so that means integration will be 0. So that means this total value has to be equal to 1. So here this also has to be equal to 1. So what do we mean by this? This means this integration here, this integration here is equal to 1. Correct? So let's try to find out this integration. K being a constant, I can take outside and I can do integration of e raised to 0.2 t dt when t is varying from 0 to 5, and this is equal to 1. Now you might have studied that integration of e raised to ax plus b, okay, with respect to x is equal to e raised to ax plus b divided by the coefficient of x, correct, plus some constant c. You might have studied this in integration in pure math 1 or in pure math 3, correct? So using the same concept, okay, same formula, what do I get? I get this as k into your integration of e raised to 0.2 t will be what? E raised to 0.2 t divided by 0.2, and because this is a definite integral, so I'll put the limits. There will be no c here, okay, and this value is equal to what? This value is equal to 1. So from this, what can I get? Can I say this is this 0.2 which is in the denominator, can I take it on the top? So it becomes what? It becomes 5k, and I'll put the limits now. So this becomes e raised to 0.2 into 5 minus e raised to 0.2 into 0. So what do I get here? And this is equal to 1. So this becomes 5k into e raised to 1 minus this becomes e raised to 0, and e raised to 0 is 1, correct? And this whole thing is equal to 1 then. So from this, can I say k is equal to 1 upon 5 times e minus 1, correct? This is what they had asked us to show. So we have done that particular stuff here. So this answers the part first of this question. Let's go to the second part. They are saying sketch the probability density function. That means they are telling us to plot the f of t. So because this f of t is an exponential function, you might have studied in pure math that an exponential function looks like this particular graph, okay, and here t is positive, basically between 0 to 5. So we will take only this particular positive section here, okay. So let's try to plot certain values. Let me drag this little bit up, okay. So when t is equal to 0, what is f of 0? F of 0 is equal to k times e raised to 0, correct? 0.2 into 0, that is e raised to 0. So this means this is just equal to k. F of 0 is k equal to k. But what is k? K is 1 upon 5 times e minus 1, correct? So if we solve this particular thing, what value we get? We get this as 0.116 something something, okay. Now when t is equal to 5, if we take, so what is f of 5? F of 5 is k times e raised to 1. So this implies f of 5 is equal to what? F of 5 is equal to e upon 5 times e minus 1. So this is equal to what? 0.316 something something. So we can plot this particular thing here. in the form of a graph. Let me bring this little bit to the right. Okay. This is our f of t with respect to t. Okay. So the graph would look somewhat like this, with this initial value here, as 0.166, or rather I can say a precise value as 1 upon 5 times t minus 1. Okay. And for this is when t is equal to 0, and for t is equal to 5, let me just enlarge this. For t is equal to 5 here, okay, what is the value it will have? It will have a value e upon this value here is 5 comma e upon 5 times e minus 1. Correct? And for the interval outside the interval of 0 to 5, f of t is 0. Correct? So f of t is 0. So that means how we will represent? We will represent by a line on the x-axis or the here t-axis. Okay. This answers our part second of the question. I'll just take the screenshot of this. This would be required in the next part. So this answers the part second of the question. Let's go to part third. What they are saying, 80% of the fireworks burn for longer than a certain time before they explode, and they are asking for this particular time period. And the f of t is also for the same thing, that it burns for a certain interval of time before exploding. The fireworks burns for a certain interval of time before exploding. So they are asking that particular time, okay, for which or for greater than which 80% of the fireworks burn before exploding. Okay. So let's try to solve that particular thing. Don't have space here. Let's take another page. Let's bring our graph. Now if you see, they are saying 80% of the fireworks burn, more than 80% of the fireworks burn for that particular period of time, or burn longer than that, okay, before exploding. So can I take this particular time interval as t1, say, for example? So this will be the section here that which represents 80% of the fireworks which burn, okay, for longer than t1 period of time before exploding. Okay. So what they have given, they have said that probability of t being greater than this t1 is 0.8, because this represents what? The probability. So if this has been given, so can I say probability of t greater than t1 is nothing but, I'm talking about only this particular interval t1 to 5. So t1 to 5 f of t dt is equal to 0.8. Correct? So let's try to find out this particular integration here. So I am integrating f of t. What is f of t of mine? F of t is k times e raised to 0.2 t dt. Okay, and this value is equal to 1. Sorry, 0.8, not 1. So this means if I integrate this one again, what I'll get? I'll get this as e raised to 0.2 t upon 0.2, and the limit is from t1 to 5 for the rest of the values. Okay, I'm not supposed to take, because I'm talking about only this particular interval, this particular region which represents 80%. So what do I get this as? I can take this 0.2 on the top. So 1 upon 0.2 becomes 5k here. This becomes 5k into e raised to 0.2 into 5 minus e raised to t1 or 0.2 t1. Okay, and this is equal to 0.8. But what is the value of k? K ka value we got it as 1 upon 5 times e minus 1 from the first part of this question. Okay, so this becomes 5 into 1 upon 5 times e minus 1, and inside the bracket what I'll get? E raised to 1 minus e raised to 0.2 t1, and this is equal to 0.8. Correct? So here this 5 and 5 I can cancel. So this ultimately I can write it as e raised to 1 is e minus of e raised to 0.2 t t1, and this e minus 1, this whole thing I'll take it on the other side of the equal sign. So if I take it on the other side of the equal sign, it gets multiplied with 0.8 e minus 1. Correct? Let's try to expand this one. So what do I get? I get e minus of e raised to 0.2 t1 is equal to 0.8 e minus 0.8. Correct? Now let's rearrange this and let's get e raised to 0.2 t1 on one side of the equal sign and the rest of the things on the other side. So what do I get? I get e minus of 0.8 e plus of 0.8 is equal to e raised to 0.2 t1, which in turn I can write it as e raised to 0.2 t1 is equal to, so here what I'll get? I'll get this as 0.2. Correct? 0.2 e plus of 0.8. Now I want to find out t1. So how do I find out t1? Because this is an exponential function here, I'll try to take natural logs on both the sides. So if I apply natural logs on both the sides, what I'll get? Ln of e raised to 0.2 t1 is equal to ln of 0.2 e plus 0.8 here, ln of this whole thing. So from this what I'll get? Because of this ln here, 0.2 t1 will come to the base here, 0.2 t1 it will become into ln of e, and this is equal to ln of 0.2 e plus 0.8. Ln of e is 1. So therefore what I'll get? I'll get this as 0.2 t1 is equal to ln of this whole thing, 0.2 e plus 0.8. So from this I can get my t1. So therefore t1 will be equal to what? T1 will be equal to ln of 0.2 e plus 0.8 divided by 0.2. So if we solve this particular expression, ln of 0.2 e plus 0.8 divided by 0.2, what do we get? We get the value something as 1.4769 something something. So this I can write in 3 significant figures as 1.48. Correct? And they are talking the time in seconds, so this will be the answer in seconds. So that means 80% of the fireworks, they burn for at least this much period of time. For at least this much period of time, okay, before exploding, or they burn longer than this much period of time before exploding. Correct? So this answers with the part 3 of the question. And with this, this particular question also ends. Hope you have enjoyed the video. Hope the video was useful. If yes, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on the channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.